Hello my dear friends, how are you all? I hope you all are fine. So my dear friends, you are very welcome in a lecture number 4 of triangles. Okay, so I hope you will enjoy this lecture. So without wasting the time, let's start. Yes, so today we are going to discuss some properties of a triangle. What is? Yes, some properties of a triangle. Okay, so now here is in this theorem. Now theorem 7.2 it states that angles opposite to equal sides of an isosceles triangles are equal. Means it is saying that let's suppose we have an isosceles triangle, okay, and it is saying that angle opposite to equal sides, and we know that in isosceles triangles two sides are equal. So let's suppose these two sides are equal, AB and AC are what are equal. So according to this, angle B and angle C are also equal. So we have to prove that angle B is equals to angle C. What is? Yes, angle B is equals to angle C. So now here, so now let's start for proof this theorem. Okay, so now here first of all we have to write the given part. Now what is the given part? So in this given part we have ABC is an isosceles triangle. Isosceles triangle. Okay, and AB is equals to AC. AB what? AB is equals to AC. So now we have to prove angle B is equals to angle C. We have to prove angle B is equals to angle C. So for proving this, we have to do some construction like we have to draw the angle bisector. Okay, we have to draw the bisector of angle A. Okay, like this AD. So this is AD is what? AD is the angle bisector. Okay, so now here is it means this angle is equals to this angle. Okay, now let consider the triangle. Okay, let's consider triangle BAD and triangle CAD. So we can write here as, you can take in triangle BAD and triangle CAD. Got it, my dear friend? So here is AB is equals to AC. This is given. AB is equals to AC. This is what? This is given part. Okay, and here is we can write as by the bisector we can write as angle BAD. Angle BAD is equals to angle CAD. Okay, so angle BAD is equals to angle CAD. So this is what? This is by construction. This is by construction. So I hope you get this point. And AD is equals to AD. So this is what? This is common. This is common. This is common, my dear friend. So here we can say that, okay, we can say triangle BAD, triangle BAD is congruent to triangle CAD. Okay, triangle BAD is congruent to triangle CAD. So this is congruence by what? By the rule of, here you can see that side angle side. Okay, you can see in the diagram. Here you can see that side angle side. Okay, and from this also side angle side. Okay, so we can say that triangle BAD is congruent to triangle CAD, and from this by the rule of simplicity we can write angle ABD is equal to angle ACD. Okay, this angle we are talking about, this angle ABD is equal to angle ACD is equals to angle ACD by here is side angle side rule, and this is by CPCT. This is what? This is by CPCT. So my dear friends, I hope you understand this thing. So this is the proof of theorem 7.2. Okay, now let's see the theorem 7.3. So this theorem states that the sides opposite to equal angles of a triangle are equal. Means it is saying that what is the sides opposite to equal angle. These sides here is we have the opposite equal angle, means angle B is equals to angle C. Okay, and the sides opposite these angles means we are talking about AB and CD of a triangles are equal. These are what? These are equal. So we have to prove AB is equals to AC in this case. Okay, so now first of all write the given part. According to this statement we have angle ABD. Okay, again we are constructing a line which is AD line, which is what? AD line, and this is the angle bisector. This is the bisector of angle A. Okay, so we can say that here is angle ABD is equals to angle ACD. Okay, this is given, and we have to prove AB. We have to prove AB is equals to AC. So this line, this condition we have to prove. Okay, so now first of all here is by construction AD, we can say angle BAD is equals to angle CAD. Okay, this is equal. So again in triangle BAD, okay, BAD and triangle CAD. Got it? So now from this we can write as here is we know that angle ABD is equals to angle ACD. This is given. This is given. Okay, I hope you understand these things. And angle BAD means this angle is equals to this angle. So angle BAD is equals to angle CAD. This is by construction. By construction. And AD is equals to AD. So this is common. This is common part. So we can write as triangle BAD is congruent to triangle CAD. Is congruent to triangle CAD. So here is this is congruence by what rule? By here is you can see that angle side rule. So two angles and one adjacent side. So this is the AD is what? It is the adjacent side. So angle side rule. So I hope you understand these things. So from this we can write as AB is equals to AC, because by the rule of CPCT. So this is what? This is the corresponding parts of congruent triangle. Corresponding parts of congruent triangles. So I hope you understand these things, my dear friends. Okay. Yeah. So now let's solve the problems. Okay. So the question number 1 is, in an isosceles triangle ABC with, we have ABC is an isosceles triangle. AB is equals to AC. Okay, and D and E are points on BC such that BE is equals to CD, means this line is equals to this line. Got it? Now we have to prove. Now show that AD is equals to AE, means we have to prove AD is equals to AE. We have to prove this line. So now we have triangle ABC. is what? Isosceles triangle. Isosceles triangle. Okay, and AB is equals to AC. Okay, so now here is by the theorem 7.2 we can say that angle B is equals to angle C. Angle B is equals to angle C because we know that angle opposite to equal sides are equal. Okay, so now we can write here as, now let's suppose in triangle, now we are taking the triangle ABD. ABD. Which triangle? ABD. Okay, and triangle ACE means this triangle ABD, triangle 1, and ACE means triangle 2. We are taking these two triangles, and we know that here is, so now we know that AB is equals to AC. This is what? This is the given condition. Okay, and angle B is equals to angle C. This is by theorem 7.2. Recently we learned about this theorem. Okay, yeah, so now here is, now we can write as, we can write what? We can write BE is equals to CD. This BE is equals to CD, this is given in the question. Okay, but this is given. Now here is, now we are subtracting DE from both the side, means we are subtracting this part DE line in from both the sides. So we can write subtract DE from both the sides. So we get BE minus DE, okay, is equals to CD minus DE. So you can see that here is, if you subtract DE from BE, we get BD, we get this line. And if you subtract DE from DC, so we get CE, we get CE. So we can write here as, so after subtracting we get, here is, this will become BD is equals to, this will become CE. Okay, so this is the side of the corresponding sides of this triangle ABD and ACE. So we can say that here is, you can see this triangle is congruent. This triangle is congruent by what? By side angle side rule, means AB is equals to AC. Okay, and angle B is equals to angle C, and BD is equal to C. So we can say that these triangles, these two triangles are congruent by side angle side rule, side angle side. Okay, so we can say, so triangle ABD is congruent to triangle ACE by what? By side angle side rule. Side angle side rule. Got it? So from this we can write as, therefore we can write this, give AD is equals to AE. This is by CPCT. By CPCT. AD is equals to AE. This line, this AD is equals to AE by CPCT. Okay, so we can write hence proof. So I hope you understand these things, my dear friends. So now let's move on. Yeah, so the next question is, in an isosceles triangle ABC with AB is equals to AC and the bisector of angle B and angle C intersect each other at point O. Okay, now join A to O and show that OB is equals to OC, and the second part is AO bisect angle A. Okay, so here is, we have triangle ABC and BO. This line BO is what? Angle bisector. Okay, and OC is also angle bisector. So BO is bisect angle B and OC bisect angle C, and we are joining this angle, we are joining this point A and O, and these lines are intersect that point O. Okay, and first, in the first case, we have to prove OB is equals to OC. We have to do the proof. Okay, so now my dear friends, here is, so now in this my dear friends, we know that AB is equals to AC. We know AB is equals to AC, and the bisector of angle B and angle C meet, intersect each other at point O. Okay, now in the first case, in this first question, here is ABC is what? Is an isosceles triangle. Then isosceles triangle. So we can write AB is equals to AC. Okay, and by the theorem we can write angle B is equals to angle C. Okay, by theorem 7.2. Okay, my dear friends, got it. So here is, if we do half of angle B is equals to half of angle C, so we get what? We can write, we get angle OBC and angle OCB. So this is what? This is equals to angle OBC is equals to angle OCB is equals to angle OCB. This is angle bisector. Okay, so here is, these two angles are equal, so we can say OB is equals to OC, because we know that side opposite to the equal angles are equal by the theorem 7.3. So here is, we can write OB is equals to OC, sides opposite to the equal angle. Sides opposite to the equal angles are equal. Are what? Are equal. So I hope you understand these things, my dear friends. Okay, so we can say hence proof. So this is hence proof. Now let's talk about the second part. Second part is what? It is saying that AO bisect angle A. AO bisect angle A. Okay, now we are taking these two triangles. Which triangles? We are taking triangle 1 and this triangle, to means triangle AOB and AOC. Now if you prove that these two triangles are congruent, then we can prove that this angle is equal to this angle, and if these two angles are equal, then we can say that AO is the bisector of angle A. Okay, got it, my dear friends? So now here is, in triangle AOB and triangle AOC, AB is equals to AC. This is given. Okay, AO is equals to AO. This is common. Here is, you can see that this AB is equals to AC and this part is common. Okay, my dear friend, and this is OB and OC are equal. This part is already proved in the part 1. Okay, so we can write as OB is equals to OC. Got it? So triangle AOB is congruent to triangle AOC. By what? By side rule. This rule we will discuss in the later. So here is, we can say this angle angle BAO, means this angle is equals to this angle by CPCT. So we can write angle BAO is equals to angle CAO by CPCT. Okay, so hence we can say AO bisect angle A. What is? So AO bisect angle A. So this is hence proof. So I hope you understand these things, my dear friends. Okay. Yes, so now my dear friends, let's move on. Yes, so the next question is, in triangle ABC, AD is the perpendicular bisector of BC. Means this line AB is perpendicular bisector of BC, means it divides the BC into equal parts and makes an angle 90 degree on BC line. So we have to prove. So now show that triangle ABC is an isosceles triangle. Okay, in which AB is equals to AC. So we have to prove AB is equals to AC. Okay, so now let's take in triangle ADB and triangle ADC. Okay, in triangle ADB and triangle ADC. AD is equals to AD. This is what? This is common. This is common. And angle ADB is equals to angle ADC. Angle ADB means this angle is equals to this angle, because they are what? They are 90 degree. They are what? They are 90 degree. This is given in the question, because AD is perpendicular bisector. Okay, and here is BD is equals to CD, since we know that AD is the perpendicular bisector. Okay, so now we can write triangle ADB is congruent to triangle ADC. Is congruent to triangle ADC. Okay, so this is congruent by what? By side angle side rule. By side angle side rule. Here is, you can see, side angle side rule. Okay, and so we can say that AB is equals to AC by CPCT. By CPCT. So we can say that triangle ABC is what? Triangle ABC is isosceles triangle. Got it, my dear friend? I hope you understand these things. Okay, so we can say, so triangle ABC is isosceles triangle. Okay, we can write as hence proof. Okay, this is hence proof. Yeah, so now my dear friends, so the next question is, ABC is an isosceles triangle. Here is ABC is an isosceles triangle in which altitudes BE and CF, altitudes, this altitude BE and CF are drawn to equal sides AC and AB. Means we are drawn these altitudes on equal sides AB and AC respectively. Okay, now we have to prove that these altitudes are equal, means we have to prove BE is equal to CF. So here is given part is AB is equals to AC. Okay, and we have to prove that BE is equals to CF. BE is equals to CF. Okay, my dear friends, I hope you get this point. And here is, we also know that BE and CF are altitudes, are altitudes, means they make 90-degree angle on the respective sides. Okay, means BE make 90-degree angle on the AC and CF make 90-degree angle on AB. Okay, and we have to prove BE is equal to CF. So now let's start. So here is in triangle AEB. Which triangle? AEB means this triangle, and triangle AFC means AFC in these triangles. Okay, we have to prove these two triangles, then we can say that BE is equal to CF by the CPCT rule. So how we can prove that? Here is angle A is equals to angle A is equals to angle A, because this is the common arm, this is the common angle, this is common angle. Okay, now here is this is what, this is the common angle. Okay, so angle AEB is equals to angle AFC. This is equal by what? Because they are right angle. They are what? Yes, they are right angles. They are equals to 90-degree, and AB is equals to AC. So this is given indication. AB is equals to AC. This is given indication. So we can write triangle AEB is congruent to triangle AFC. Is congruent to triangle AFC, because by here is you can see that angle side rule, angle side rule. So we can say that BE is equals to CF by CPCT. By what? By CPCT. So here is, so these altitudes are equal. These altitudes are equal. Hence proof. Okay, I hope you understand these things. So now let's move on. Yes, so the next question is ABC and DBC are two isosceles triangles. Here is ABC and DBC are two isosceles triangles on the same base BC. So we have basis BC which is same. Okay, now we have to prove angle ABD, angle ABD equals to angle ACD, means angle ACD. So okay, so we have to prove this angle equals to this angle. Got it? So how we can prove that? Let's see. So in the question it is given that ABC and DBC are two isosceles triangles. So given part is what? Given part is ABC and ABC, triangle ABC and triangle DBC are isosceles triangle. Isosceles triangle. So here is we can write as now, and we have to prove that angle ABD is equals to angle ACD. Okay, my dear friend. So first of all, here is we can say that by the isosceles triangle property, this angle is equals to this angle. This angle is equals to this angle. Got it, my dear friends? And similarly, we can say that this angle is equals to this angle, because these two sides are equal. Okay, so here is angle ABC is equals to angle ACB. Okay, this is by theorem 7.2. Okay, and this is equation number 1. And similarly, angle DBC. Angle DBC is equals to angle DCB. Again, this is by theorem 7.2 and this is equation number 2. Now we are adding these equations. Now add equation 1 and equation 2. So here is we get what? We get angle ABC plus angle DBC. Angle ABC plus angle DBC is equals to, this will become angle ACB plus angle DCB. Angle ACB plus angle DCB. Okay, now after adding this, if we add this angle and this angle, we get complete this angle. So we get angle ABD. We get angle ABD is equals to, if we add this angle and this angle, we get complete angle ACD. We get angle ACD. We get angle ACD. So this is the required result. So we can say hence proof. So with the help of theorems, we can prove that angle ABD is equals to angle ACD. I hope you understand these things, my dear friend. So this is hence proof. Okay. Yes. So now, yes. So the next question is, ABC is a right angle triangle in which angle A is 90 degree and AB is equals to AC. Okay, AB is equals to AC. Now find angle B and angle C. Angle B and angle C. So here is AB is equals to AC. So we can say that triangle ABC is isosceles triangle. Isosceles triangle. Okay, and by the isosceles triangle property, we can say angle B is equals to angle C. Angle B is equals to angle C. This is by theorem 7.2. Okay, so this will become, here is, we know that by angle sum property, the sum of all the angles, sum of all the interior angles is equals to 180 degrees. So angle A plus angle B plus angle C is equals to 180 degree. Okay, and we know that angle A is 90 degree plus angle B plus, we can write angle B in place of angle C because both the angles are equal, and we can write angle B which is equals to 180 degree. Now twice of angle B is equals to 180 minus 90. This is equals to 90 degree. So here this will become angle B is equals to 90 upon 2. This is 45 degree. So angle B is equals to 45 degree. Angle B is equals to 45 degree. This is the correct answer. If angle B is equals to 45 degree, then angle C is also equals to 45 degree. This is the correct answer. I hope you understand these things, my dear friends. Yes, so now next question is, show that the angles of an equilateral triangles are 60 degree each. Okay, now we have to prove that angles of equilateral triangles are 60 degree. Okay, so here is, we have an equilateral triangle like this. Okay, and we know that in equilateral triangles all the sides are equal. All the sides are equal. So here is BC is equals to AC is equals to AB. Okay, since length of all sides is same in equilateral triangle. Okay, so here is, so we know that AB is equals to AC. So means angle opposite to these sides are equal. means we can write angle B is equals to angle C. Okay, and AB is equals to AC. So again by theorem, this AB is equals to AC. Again by theorem, angle opposite to the sides, equal sides are equal, means angle C is equals to angle A, means angle C is equals to angle A. Okay, got it? And again, if BC is equals to AC, then angle A is equals to angle B by theorem. So angle A is equals to angle B. So from these we can write angle A is equals to angle B is equals to angle C. So we can write reason angles opposite to the equal, okay, angle opposite to the equal sides are equal. Okay, I hope you understand these things, my dear friends. Here is also we know that angle A plus angle B plus angle C is equals to 180 degree. Okay, and here is we know that all these angles are equal, so we can write angle A plus angle A plus angle A is equals to 180 degree. Okay, so this will become thrice of angle A is equals to 180 degree is equals to 180 degree. So this will become angle A is equals to 180 divided by 3. So this is equals to 60 degree. So here is angle A is equals to angle B is equals to angle C is equals to 60 degree. So hence proof. Okay, so I hope you understand these things, my dear friends. Yes, so now the next question is, here is triangle ABC is an isosceles triangle. This triangle ABC is an isosceles triangle in which AB is equals to AC. This line AB is equals to AC and side BM is produced to point D such that AD is equals to AB, means AD is equals to AB, means we can say that AD is also equals to AC. Okay, now we have to prove, now show that angle BCD means this angle is a right angle. Okay, we have to prove this. Okay, my dear friend, so now here is it is given that AB is equals to AC, okay, and AD is equals to AB. Okay, and we will have to prove angle BCD is right angle. Okay, so now let's start. So now in triangle ABC, okay, we know that AB is equals to AC. Okay, it is given part, and also ACB means this angle is equals to ABC, because angles opposite to the equal sides are equal. Okay, so angle ACB is equals to angle ABC, because we can write angle opposite to the equal sides, means angle opposite to the equal sides are equal. So here is now in triangle ABC, means in this ABC triangle, we know that this sum of all the interior angles is equals to 180 degree. So we can write here as angle CAB plus angle ACB plus angle ABC. This is equals to 180 degree. This is equals to 180 degree. Okay, and we know that angle ACB is equals to angle ABC. Okay, so here is we can write angle CAB plus twice of angle ACB, twice of angle ACB is equals to 180 degree, is equals to 180 degree. So angle CAB, this will become 180 degree minus twice of angle ACB, twice of angle ACB. So this is equation number 1. And similarly in triangle ADC, we know that AB is equals to AD and AB is equals to AC also. So from this condition we can write AD is equals to AC. Okay, so angle, we can say angle ADC is equals to angle ACD, is equals to angle ACD. So again in triangle ADC, the sum of all the angles, all the interior angles are 180 degree. So we can write here as angle ADC plus angle ACD plus angle CAD. This is what? 180 degree. And we know that ADC is equals to ACD, ADC is equals to ACD, and from this angle CAD plus twice of angle, we can write twice of angle ACD, which is equals to 180 degree. So this will become angle CAD is equals to 180 degree minus twice of angle ACD. So this is equation second. This is equation second. This is what? This is equation second. And here is, since here is, we can write BD is a straight line. BD is a straight line. Okay, so angle CAB plus angle CAD is equals to 180 degree. We can write linear pair. Linear pair. So from this, now here is angle CAB, angle CAB, angle CAD, and here is angle CAD. So from equation 1 and 2, so we can put the value of angle CAB and angle CAD in this equation. In this equation, so we get here is 180 degree minus twice of angle ACB. This 180 minus twice of angle ACB, and plus we are putting 180 minus twice of angle ACD in place of angle CAD. So we get 180 degree minus twice of angle ACD. So this is equals to 180 degree. Okay. Now here is this 180 degree and this 180 degree will be cancelled. So we get here is, this will become minus twice of ACB and minus twice of ACD is equals to minus twice of angle ACB minus twice of angle ACD plus 180 degree is equals to 0. So this will become twice of angle ACB plus this will become plus twice of angle ACD is equals to 180 degree. Okay, so here is, we are taking 2 as a common. This is angle ACB plus angle ACD is equals to 180 degree. So we get angle ACB plus angle ACD is equals to 180 divided by 2, we get 90 degree. Okay, and this angle is, if we add this angle, we get angle BCD, which is equals to 90 degree. So this is a very good question. Okay, you have to be remember this question. Okay, you have to do the practice. So this is hands pro. This is hands pro. So I hope you understand these things, my dear friends. So now this is enough for today, and we will meet in the next lecture with the next amazing topic. So thank you very much for listening me, and take care and goodbye.